When we know the probability, but don't know the z value, then it's the percentage points of the normal distribution tables that we need to use. So this table gives us the probability along the top and down the side, and the z values at the main part of the table. So once again, it's area to the left of the z value. So in part A, if we're finding the probability z is less than some number a, but we know it's 0.992, then on a diagram, this would mean a must be positive. I've put it between 1 and 2, but it might be bigger than 2. The important thing is that 0.992 is the area, which is the probability. So we're going to the percentage points tables looking for a probability of 0.992. This first table gives us probabilities to 2 decimal places, and the second table gives probabilities to 3 decimal places. So for part A, the probability is 0.992. We're going to be looking at the second table. So go down to 0.99 and then across. So the third decimal place is 2, and there's our z value, 2.409. So I just placed it randomly between 1 and 2 before. Turns out it's actually bigger than 2, so it's a bit further along. In B, similar situation, but this time the area is importantly less than a half. Because it's less than a half, then I know A must be negative, somewhere on the left of the distribution, of the middle of the distribution. I'm just going to place it there. I'm not saying it has to be between -1 and -2. I'm just placing it there. So we know this area is 0.35, so we know our A value must be negative. The problem with that is, looking at the tables, we don't get given any negative z values. But A is a z value because it shows up here. It doesn't give us any negative z values. So again, we need to use the symmetry here. If A is there, and we know A is negative, then if we times it by -1, we'll get negative A, which will actually be a positive value because it's on the right hand side. And from symmetry, that area there will be 0.35. It's very important that you remember all these values are the area to the left of a z value. We have here the area to the right of 0.35, so the area to the left of negative A, so area to the left of this point here, must be 1 minus 0.35, which is 0.65. So I can change this statement to be the same as 1 minus the probability z is smaller than negative A. So area to the left, total area to the left is 0.65. I'm going to look up 0.65 as a probability. That's 2 decimal places, so I'm up here. 0.65 is there, 0.385. So that value there is 0.385. That's the z value, is 0.385. And remember that's negative A, so A must be negative 0.385.